Hello everybody. Prime numbers, Python solution. So what we're going to do is we're going to look at prime numbers and why they're useful. We'll look at some pseudo code to solve prime numbers. Then we'll make some Python code that prints prime numbers to the screen. We'll look at some equivalent C code. The purpose of this video is to concentrate on solving the problem. The core concept is the same whether we're writing in Python, C, or any other language for that matter. The task is to print all primes in the range from 0 up to 100. Prime numbers are special numbers greater than 1 that have exactly two factors, themselves and 1. So a prime number, such as 19, can only be divided by 1 or 19. It can't be divided by 3, 5, 10, etc. Prime numbers are fundamental to the most common type of encryption used today, the RSA algorithm. Every time you send your credit card number to a website, you're depending on primes to keep your details secret. The reason why prime numbers are so magical, you can multiply the two together, but once you've multiplied two large prime numbers together, it's impossible to work out how you got there. Impossible to pull them apart. Okay, right, let's look at some pseudocode on how we're going to solve this. So for every number, we'll call it n, from 1 up to 100, we want to check, can it be divided by any number between 2? The reason why it's 2 is because we discard 1, because 1 could be a prime or it could be a non-prime. So we're going from 2 up to the number. So if we're checking if number 19 is a prime, then we're going to go from 2 up to 18. There's no point checking if 19 can be divided by 19 because that could be a prime or a non-prime. So if we divide it by any number between 2 and 1 less than itself, if we use modulus, we can check if that will return a 0. If it doesn't return a 0, then it's prime number. So this function in Python, call it checkmod. So I can be any number between 1 and 100. So, and n, we can set n equal to I to start with. But any number in the range between 2, so if we go back to the 19 as our example number, we can go from 2 up to 19, and then we'll say, 19 minus 1. Then we'll say if the current iteration, so that's the iteration between 1 up to 100, we'll say if that, so if we're checking if 19 can be divided by 2, but returns a 0, then it's an even number. If we're checking, for instance, if I is 19 and n is 2, that will give us a modulus of 1. So modulus basically is you're looking at the remainder and you're checking to see whether the remainder is equal to 0. And obviously if you divide 19 by 2, then you get 9.5, so you don't have a remainder of 0. Then what we do is we iterate from 1 to 100, and the result actually is the result of our function. So if a function has passed us back a 0, then it's not a prime. If a function passes us back a non-zero, i.e. if it's not 0, then we print this prime number, and then we'll get a list between 0 all the way down to 100, telling us whether each number between 0 and 100 is a prime or not. So what we'll do next is we'll compare against C code, and then I'll actually demonstrate the code. This is in C, so although it looks different to, well, obviously it looks different to Python, this is the function. And as you can see, here we have n minus 1 again, and n minus 1, and we're just using a different variable name here, so m instead of n. m minus 2, and then m up to the number itself minus 1. And then we're just going to keep iterating upwards. And then we say if n modulus m is 0, so we'll iterate through all of those, and if we get a 0, then we'll return it back to our main code, and if we get a 1, we'll return that back to our main code. So it'll send either a 0 or a 0 as the return response. So this is the main code, and again, much like the Python, we're going that should actually be I should equal 100. It's not, for the purposes of this, it's irrelevant. Then what we say is if the function sent us back a 1, then we say it's a prime number. If the function sent us back a 0, then it's not a prime. And for those of you interested, if you create a flowchart, you could actually write it in any language, or you could give it to somebody and they could write it in JavaScript or C# or whatever. This is a flowchart which I used an online generator for, so it's not to my taste, but it shows what is happening really. So we start off with int main, then we come down here, and if the number's less than 99, then we keep going, and then if the result is 1, then we print a message, otherwise we keep going, and then we keep passing to this function. So this bit on the right is the function, and this is the main body. Anyway, right, so both solutions use a function. We're looking at the similarities here between the Python code and the C code. And really the emphasis here is Python, C, whatever. We'll use function, 2 loops, and modulus. So with prime numbers, the best way to solve prime numbers is to use modulus. So the logic is the same, the syntax is all it changes. Okay, good. So let's just run through the examples and we'll wrap this up. Okay, so let's look at the Python code. And we've got a function. The function contains a for loop, which is iterating through 2 up to the number -1, where number is the number of the current iteration. Then we're going to get the result of that function, and if the result of that function equals 1, then we're going to say it's not a prime number. Otherwise, we'll say it is a prime number. Let's run it. If you're ready, run the code. And there we go. So let me just expand that for you. And there we see it. We have right up from 2 as a prime. We didn't do 1, did we? In fact, let's just fix that. Wrong place, sorry. We need to change it here. Okay. Right, run it again. And now we see 1 is a prime number, 2 is a prime number, 3 is a prime number, 4 is not, 5 is, and so on. I'm sure you can all get the gist of that. The one I always remember as being a prime number is 13. It's a prime number, and so is 19. So there we go. That is how to solve it using Python code. So just one last look at that. What we did was we run the function which iterates from 2 up to the number. Okay, and just for completeness, this is the version written in C. So C is slightly different if you're not familiar with it. You can declare a function prototype before the main body, and then the best practice is to actually write the function after the main body. So what we've done here is we've used the 2 and the n-1 again, and we've used the increment by 1 through the for loop, and then we're returning, here we're going to return 1 if it's a prime, and we're going to return 0 if it's not a prime. So, and then back in our main function, we're going to set the result equals the return value of the function. We're going to go from 0 up to 100. So let's run that, and it should give us pretty much the same result. And let's have a look. I think it has. What have we got here? Yeah, we have 0 is not a prime. 1, 2, 3. So yeah, 1, 2, 3, 5, 7, 13 is a prime, 19 is a prime. So I think you've got the idea. Hopefully that's just giving you some kind of food for thought on how you can solve the problem using pseudo code or with a flowchart, and then you can apply the same logic and focus on solving the problem first rather than actually writing the code, because actually once you get used to it, writing the code should actually become the easier part. So there we go. how to solve problems and write in Python and in C. So hopefully this has been interesting. Any questions, drop me a line. If you want to do your own versions and send me the link, or yeah, do your own video, be really cool. So thumbs up because of the algos. Yeah, thanks.